Part 2. We found the slopes of each line. I need to find the actual equation of each line. So, if you guys remember from grade 9, our equation of a line is y equals mx plus b. Okay? So, that means I want both of these diagonals written in this form, y equals mx plus b. I'm writing them above so I know how to plug things in. Now, luckily I've already discovered the slope, so I can plug that into our formula. We'll keep this in blue, since we're working in blue. Y equals, our slope is right here, negative 1 over 3. So I replace the m with negative 1 over 3. So I've replaced the slope with negative 1 over 3. That's great, but I still have 3 other variables. I have a y, an x, and a b. Now technically, I only need to solve for the b to get the actual equation of a line, which means I need values for x and y. Now x and y could represent any point along this line. So if I look back up to the top again, we're working with line PR. I have points right here. Point P is on this line, and point R is on the line. So I can use either of those coordinates. I'm going to choose to use point P. Okay, so we'll underline it. We're going to use point P, which is negative 2 and 1. So I'll bring this back all the way down. Right above it, point P is negative 2 and 1. So negative 2 is an x value somewhere along the line, and 1 is a y value on that line. So I can substitute negative 2 in for our x and 1 in for our y. So we'll do that again. So our y gets replaced with 1. And our x gets replaced with negative 2. So, now that I've got a value for a y, value for m, value for x, I can easily solve for the b. The b is going to be the y-intercept of this line. So I just carry out bed mass. This becomes 1 equals 2 over 3 plus b. b equals 1 minus 2 over 3. b equals a third. Okay, I did that quickly in my head. We have our b. So, I can actually have an equation of a line right now. We knew that the slope was negative 1 over 3, and I know that the y-intercept is positive 1 over 3. So, y equals negative 1 over 3 x plus a third. This is our slope, this is the equation of our first diagonal, our diagonal PR. I want you guys to try to duplicate right now what I just did with the other diagonal. Okay? So take a minute. Try solving the slope, x and y, y-intercept, and getting the equation of one of the lines. Okay, so we're now working with line QS. I'm going to do this all in black. Y equals, I'm going to zoom in just a little. Okay, y equals, our slope for our line QS is 3 over 2. So I'm replacing m with 3 over 2. So 3 over 2x plus b. Y equals 3 over 2x plus b. Now I need to replace my x and y again with a point. If I go back up to the top, okay. So Q and S, we have our points up here. We're going to use point Q, but it doesn't matter which one we use. We could use Q or S because they represent a point along this line. So we're going to take point Q, which is 3 and 3. And we're going to substitute. That goes in for our x value. So 3 goes in for our x value. And our y value, we plug 3 in for that also, plus b. Once I've done that, carry out bedmass to solve the rest of this equation. So 3 is equal to 9 over 2 plus b. Bring 9 over 2 to the other side. Now I know this confused a lot of you guys last time, so I'm going to carry out the steps. I have to turn 3 into a fraction with a denominator of 2. So what that's going to look like is you're going to end up as 6 over 2, subtract 9 over 2 equals b. So I'm doing an extra step that I didn't do last time. 6 subtract 9, negative 3. I leave the same denominator, so it's negative 3 over 2, b. So our y-intercept for our other line is negative 3 over 2. That's pretty convenient. So y equals, so the equation of this line, y equals positive 3 over 2, x minus 3 over 2. That's our y-intercept. Just so happens the slopes and the y-intercepts are quite similar. Yeah. Okay. So let's go back up and verify. Let's make sure that makes sense. Negative 3 over 2. There's a y-intercept. Yeah, it makes sense. This looks like it's roughly at negative 3 over 2, and this one looks like it's at around positive a third. So those y-intercepts make sense. Our slopes make sense. Everything seems to be working so far. We now have the equations of our two lines. I need to find where they bisect. So where are they going to cross each other? This goes back to Chapter 1. Elimination, substitution, graphing. Looking on the graph from the previous page, I couldn't tell you exactly what that point is. It's somewhere in between whole numbers. So I'm going to use substitution because I've already set both of these equal to a variable. Okay? Even though it's the equation of a line, it is set equal to one variable. I can now use substitution to solve for our variables. So y is equal to this expression here, negative 1 over 3x plus 1 over 3. I could substitute that value into the y of the other equation. So what that's going to look like is we now have, well, we'll do it here. Negative 1 over 3x plus 1 over 3 is equal to 3 over 2x minus 3 over 2. So using substitution, I set these two equal. I got rid of the y and I replaced it with the other expression. So now all I have is one variable throughout this entire equation. X. I'm going to try to solve for the x. A quick way to get rid of all these fractions is to multiply this entire equation by a common multiple of 3 and 2. So I need to find a common multiple of 3 and 2. 6 would be a great number. So I'm going to multiply this entire equation. That means every term in it by 6, so that I'm no longer working with fractions. So we're going to multiply everything by 6. When I do that, I get negative 6 over 3x plus 6 over 3 equals 18 over 2x minus 18 over 2. Well, I can divide all of those. That's why I chose to multiply that number. Negative 6 over 3 is negative 2x plus 2 equals 9 over x minus 9. Now I'm working with whole numbers. Got rid of all my fractions. Much easier to work with. I'm going to put all the x's, so any term that has an x in it, a variable, to one side, anything with a constant to the other. So I'm going to move this 9x to this side, and I'm going to move this positive 2 to this side. I'm going to do this all in one step in the interest of time, okay? So negative 2x minus 9x is equal to negative 9, and this 2 becomes negative, minus 2. Okay? This will become negative 11x equals negative 11. Lo and behold, x equals 1. So where they cross each other, these two lines, these diagonals, they cross at x1. I just got to find the other coordinate. I'm going to use substitution again, back into one of our other equations from above. In fact, what we'll do is we'll take y equals negative 1/3 x plus 1/3, and we'll substitute in. Y equals negative 1/3 x plus 1/3. I'm going to substitute this value in for x to solve for y. So this goes into the x. Okay, let's finish this. We substitute that in for x. Look at that. Y equals 0. So, the diagonals of these lines cross at the point 1 and 0. If we take a look, that makes sense. Right there. 1 and 0. That's where the two diagonals cross. So we've proved it now.